Welcome to The Explainer. Today, we're looking at something absolutely wild. I'm going to show you how the world of software development is, right at this very second, crossing a massive historical threshold. We are literally entering an entirely new era of coding, and the way humanity builds software is fundamentally changing right before our eyes.
Let's actually kick this off by jumping back to the late 1970s for just a minute. Think about the original Star Wars film. The team behind that movie didn't just tell a great story, they completely revolutionized film technology. They used this thing called the Dijkstraflex camera. Before this, camera work was entirely manual. But the Dijkstraflex, that was a computer-controlled system that allowed for exact, perfectly repeatable camera movements. It meant they could shoot scale models in layers and combine them into incredibly seamless shots, entirely without humans in the loop controlling the camera at that exact moment. It was a total game changer that made the sci-fi fantasy a reality.
Section 1. The Technology Boundary Line.
So, that massive cinematic leap perfectly illustrates what we call a technology boundary line. It's a defining innovation that permanently separates an industry's before period from its after period. And just like that Dijkstraflex camera redefined filmmaking, we're sitting on a similar boundary right now. AI agents are actively drawing a definitive line in the sand for how humanity builds software. The old ways, they're rapidly becoming ancient history.
Section 2. The weight of traditional code.
To really grasp why this new era is such a revolution, we kind of have to look at the incredibly tedious way we used to build things just a few years ago. Think about a massive Gothic cathedral. When you walk up to it, you immediately see and feel the incredible complexity and the sheer weight of what it took to build it. It wears that complexity proudly on its sleeve. Software, however, is the exact opposite. Software's massive complexity is entirely hidden away.
And because product managers, or really any non-technical folks, only ever see these simple, clean buttons on a screen, they often get super frustrated. They'll ask for what seems like a totally minor change, and they're just baffled by how slow and expensive it is for the engineering team to actually make it happen. They usually assume the engineers are just dragging their feet. What they don't see are the tens of millions of lines of incredibly complex logic operating underneath those simple buttons.
Historically, engineers had to painstakingly take these high-level thoughts and manually translate them into tiny, meticulous bits of logic. I mean, we're talking about writing out tedious if this, then that statements in extremely verbose, formal programming languages. If you wanted to make a change, you weren't just writing a simple script, you were wrangling tens of millions of existing lines of code, often tweaking thousands of files just to make one tiny adjustment. This manual burden is exactly what drains R&D budgets to the tune of hundreds of millions of dollars.
Section 3. Rise of the Agents.
Okay, let's look at the data and see how fast this manual coding is vanishing. We're progressing through some very distinct evolutionary stages here. We started in Era 1, writing formal programming languages entirely by hand. Then we moved to Era 2, the tab accepts era, kind of like text message autocomplete but for small snippets of code. But right now, we're shifting into Era 3 and Era 4. We are moving away from tiny autofills and instead delegating massive, end-to-end bodies of work to autonomous AI agents and eventually entire agent teams.
And the sheer explosion of these agent requests is honestly breathtaking. Over the course of 2025 alone, agent requests have seen a greater than 15x year-over-year increase. At the start of the year, engineers were still using standard autocomplete 10 times more than agents. But now, that ratio has completely flipped. Agent requests have overtaken tab accepts, which is monumental, because an agent request isn't just a few lines of code, it's usually a giant body of complex work.
And get this isn't just happening at tiny experimental startups. This is hitting the big players. An astonishing 75% of code in the enterprise segment is now entirely AI-generated.
Just think about that adoption speed for a second. Literally a year ago, that number was sitting at maybe 15 to 20%. Today, the leap is staggering. It means human engineers are rarely touching the actual code syntax themselves anymore. They're completely delegating the actual typing and syntax generation to the AI.
Section 4. Engineers as agent managers.
So this massive shift basically tears up the traditional job description of a software engineer. Welcome to your new workforce. Instead of manually typing out code, engineers are essentially becoming managers. The new mental model is that you aren't just working with a few thousand human engineers anymore. You're now managing tens of thousands of highly capable ghost colleagues. These AI agents run autonomously on remote cloud servers, sometimes grinding away on complex tasks for days at a time, entirely in parallel.
And hey, best of all, they don't drink all the break room coffee.
But, and this is a big but, this transition comes with some huge risks. If you aren't careful as you move into this Teams era, these ghost colleagues can easily cause some serious damage. You can end up generating massive amounts of unsustainable code, making totally poor architectural decisions, and creating systems that are completely riddled with bugs. It's a very real danger if human oversight isn't adapted properly.
To combat those exact risks, the modern engineer's role has radically evolved. They're moving away from writing syntax and manually editing files. Instead, their future is all about heavy multitasking. We're talking babysitting and feeding tasks to dozens of parallel agents at once. The human engineer is now the editor-in-chief, spending their time reviewing the generated syntax and aggressively testing the architecture to ensure it actually holds up in the real world.
Section 5. The autonomous software future.
Okay, so where is all this unprecedented parallel processing, multitasking, and delegation actually leading us? Well, to test the absolute limits of this, an experimental team of autonomous AI agents was set up. And on their own, they generated a staggering 3 million lines of code. What were they building with all that? Without a single human intervening, this team of AI agents worked together to build a functional prototype web browser entirely from scratch. And they did the whole shebang in just a single week.
Now, to be fair, it wasn't perfect right out of the gate. Day one looked pretty rough. It couldn't render pages properly at all. But by midweek, the agent team was rapidly generating thousands of files and autonomously building all the complex connections between them. And by the end of the week, this autonomous team had spun up a massive, interconnected codebase that actually yielded a mostly functional web rendering system. It actually worked.
While this specific experiment is obviously still pretty nascent and not exactly ready for prime time, it serves as an incredibly powerful glimpse into the far future. It leaves us with one absolutely fascinating question to ponder about the future of human creativity. If AI teams can autonomously build an entire web browser from scratch in a single week today, what on earth will they build tomorrow? Thank you so much for exploring this boundary line with me. I'll see you in the next explainer.